Hello, welcome everyone. Welcome back to my channel. Today we are diving into super important part of our calculus, which is maxima and minima. Well, if you think that how to find the highest or the lowest point on the graphs, obviously this video is for you, and we'll be using differentiation to find these turning points. Now, as you see this graph, you can clearly see that it has a highest point and a lowest point, like this. This one is the highest one and this one is the lowest one. Now, in the previous videos, we have already seen that what is the first derivative of a function will give you. It basically gives you the slope of a function, and that will give us idea to find the stationary point, because first derivative gives you the slope of a particular point. And in increasing and decreasing function, I have explained you that why the gradient is positive and why gradient is negative in case of increasing and decreasing functions. So I have explained you the geometrical interpretation as well as the calculus part. So same thing, we're repeating it here. That means to find the maxima and minima, the slope is very important. Take the example of this one. Now, whether the point is a maxima point or a minima point, in both the cases, it's called stationary point, because this is the point where the function is neither increasing nor decreasing. Like take the example of this one. Here you can clearly see the function is increasing, and at this point, it's how you will mention, is it increasing or decreasing? Nothing is happening. So this is called stationary point, and then after it takes a turn, and that's why this is called turning point as well, and the curve starts to decrease. Same I can say is happening here. The curve is decreasing and reaches to a turning point where it will change its behavior and starts to increase. So this is stationary point. Now stationary points are two types, maxima and minima. Obviously the highest value will give me the maxima and the minimum point will give me the minima. Clearly, apart from this point, there is no point which is greater than this point, and that's why y value, I'm talking about the y value in this case, there is no one which has the y value greater than this one, and similarly there is no point which has the least value of y than this one. So we can find these stationary points using the help of a slope. If I draw a tangent at this point and similarly draw a tangent at this point, you can clearly see that the slope of this tangent is parallel to x-axis, or I can simply say it's 0. So in calculus, we know how we can calculate slope of any curve. It's by finding the derivative, which means dy over dx. And whether it's a maxima point or a minima point, the dy over dx, the slope of that particular point is 0. Slope of these tangents is 0. So I need to equate it to 0. So at least this will help me in finding the stationary points. Now the question is, if I find dy over dx and I get to know that this is 0, how would I know whether this is maxima or minima? Because in both the cases we are going to get 0 as the answer, but for any particular curve, not necessarily a quadratic, cubic, fourth power, any sort of curve, after differentiating, how would I know that whether it's a maxima or minima? So for that we have to find the second derivative. So second derivative reveals the information about the concavity of a function's graph. Second derivative, that means we have to differentiate one more time, which is d2y over dx2. So as I told you, it tells you about the concavity of the graph. That means it tells us whether the graph is curving upwards, that is concave up, or downwards, concave downwards. That means, say for example, I'm talking about this one. So what is this curve, this hole? You can clearly see this is basically concave up. That's called concave up, and this is called concave down. So if the second derivative is positive at a point, the graph is actually concave up. And if it's a concave up, it indicates that the slope of the tangent line is increasing. That means I'm talking about actually this part. This shape is called concave up. And when our second derivative is positive, it shows that this is concave up. This whole part is concave up. And if I'm getting a stationary point at a curve which is concave up, is obviously the minimum point. That means for the condition to get a minimum, my second derivative should be greater than 0. This is most common mistake, because in increasing and decreasing function we have seen that dy by dx is greater than 0 makes it increasing and lesser than 0 makes it decreasing. But that's a slope concept. But students get confused between it, and whenever we talk about the maxima, they think, okay, it has to be greater than 0. So second derivative has to be greater than 0. No. Second derivative, if it's positive, it will give you the idea that this is concave up, and this shape is called concave up, and we get a minimum point at this. Whereas if the second derivative is negative or shorter than or smaller than 0, it means this shape indicates concave down, and this concave down will definitely give you a maximum point. So for the maximum point, the condition is d2y over dx2 should be lesser than 0, whereas for minimum it has to be greater than 0. So we got to know that when we find the double derivative, and if it's lesser than 0 it's maxima, if it's greater than 0 it's minima. But what if you will get it 0? Then what it would be? So when you will get the double derivative 0, that means here the curve is actually changing from the concave up to concave down, or vice versa. Just like this one, here you can clearly see this is entirely concave down and this is entirely concave up. So what's happening here? This point is actually changing the course of this curve, and this is the point where you will find the second derivative be 0, and hence this is called point of inflection. Now let me tell you one thing, that your slope is not equal 0 in this case. You can clearly see here it's changing its concavity, but at this point if I'll draw a line to know the gradient, right, that is the tangent, it would be like this, somehow like this. And you can clearly see that this one is not 0, this is a negative gradient in that case. So gradient is not always 0, but in some cases it can be. Let me show you that one. This one here, clearly you can see that this point is something where the concavity is changing, obviously. So we get to know that d2y over dx2 is clearly 0 in this case. But at the same time, here this slope is also 0, because if I'll draw the tangent at this point, I can clearly see that this is parallel to x-axis and it's 0, which means dy over dx is also 0. We can clearly see that this function is increasing here and will get a positive slope, whereas at this point, this is decreasing function and it has a negative slope. This is the maximum point, and this whole shape is called concave down. So when it's a concave down, it's actually will get a maximum point. The condition for this, for the increasing function, because the positive slope, that means dy over dx has to be greater than 0, whereas for decreasing function where we'll get the negative slope, dy over dx has to be less than 0. And at maximum point, d2y over dx2, that means double derivative should be lesser than 0, because that shows the concave down behavior, whereas here when it's concave up and when I'll find the second derivative, it will give me the positive value. But when we are getting d2y over dx2 as greater than 0, we'll get the minima point. Now the maxima and the minima are of two types. It's local maxima minima or absolute maxima minima. See this graph. There are so many peak points here. That means there are so many maxima here. This is maxima, clearly. This is maxima. This is maxima. This is maxima. If your maxima point is in a given range, say for example, here this is x is equals to -3 and this point is x is equals to -2, say for example, and if I want to know that is there a maxima point between -2 to -3, so that will be this one, and hence this is called local maxima. That means we have a maximum point but in a given range, a given domain. Similarly here, this is a minimum point, but that's a minimum point in a given domain. But if I'm talking about the absolute maxima, that means when I'm going to compare every maxima of this curve, the highest maxima of all those maxima points will give me the absolute maxima, which is clearly this one. This one is the peak one. It's the highest one. So this is, so throughout the domain, this point is proving that this is the maximum point, so hence this is called absolute maxima, whereas in this case this proves that the most minimum point throughout the domain of this curve, and hence this is called absolute minima. So this is basically the graphical understanding of it. Now let me see how we can solve these questions using calculus and how can we do the questions for A levels. Now for the question 1, it says for a function y is equals to x cubed plus 4x squared plus 4x plus 5, find the coordinates of maximum point. To calculate the points for the maximum point, you just have to differentiate it one time, okay, and equate it to 0, because obviously we are finding the maximum point. Maximum point is a stationary point where the slope is 0. So I have to differentiate it one time and equate it to 0. And that will give me 3x squared plus 8x plus 4. Now let me equate this to 0. This is a quadratic one and I can easily factorize it. The product is 12 and the sum is 8, which means 3x squared plus 6x plus 2x plus 4. Obviously, the product is 12 and sum is 8. So two numbers are 6 and 2. Taking out 3x is common, x plus 2. And 2 is common, x plus 2. That will give me 3x plus 2 times x plus 2 is equals to 0. So x1 is equals to -2 over 3 and x2 is equals to -2. Now I got 2 points. I have to think that which point will give me the maximum or minimum. If you'll get 1 point and up there it's mentioned find the maximum point, it's very easy. But if you got 2 or more points, what you have to do is you have to double differentiate it to know whether this point is going to give you a maxima or minima. So when I'll double differentiate it, it will give me 6x plus 8. I need to substitute each of them to know that which point is giving me maxima and which point is giving me minima. So let me substitute here -2 over 3 plus 8. That will give me 4. So d2y over dx2 is positive in this case. That means I'll get minima. So this will give me minimum. So this one will give me maximum, but even though, let me check. So 6 times -2 plus 8, which is -4, and less than 0, that means yes, this will give me maximum. If x equals -2 will give me the maxima, so the coordinates for x is -2 and for y I just need to sub in here. That will give me -8 plus 16 -8 plus 5, and that will give me 5. So the coordinates of the maximum point is -2, 5. Part B says find the coordinates of the minimum point. We have already calculated -2 over 3. That's for the minimum point. And the coordinates for y will be just substituted here. So minus 2 over 3 will give me 8 over 27 plus 4 times 4 over 9 plus, that should be negative, 4 times negative 2 over 3 plus 5. So that will give me 103 over 27. Now question 2, a curve C has equation f of x is equals to ax squared plus bx plus 3 where a and b are constants. Find the values of a and b if f1 is 7 and f negative 2 is 1. So it's very simple, we just need to substitute. That means for this one, when x is equals to 1, y is 7. So substitute here f of x, that will give me 7 and it will give me a plus b plus 3, and from here I'll get one equation, a plus b is equals to. For f of negative 2, that means x is equals to negative 2 and y is equals to 1. I have to substitute here y as 1 and x as minus 2 will give me 4a minus 2b plus 3, or that will give me 4a minus 2b is equals to minus 2. Divide both the sides by 2. I'll get 2a minus b is equals to negative 1, my second equation. This is basically the simultaneous equation we have to solve. I'm solving it here. A plus b is equals to 4, my first equation. And my second one is 2a minus b equals minus 1. Add them up will give me 3a equals 3. A is 1. On substituting a as 1, I'll get b as 3. So the values of a is 1 and b is 3. Find this graph has maximum point or minimum point. We have to find whether this graph has a maximum point or minimum point. Now we have the equation because we have already calculated the a and b. So a is 1 and b is 3. So that will make it x squared plus 3x plus 3. Now differentiate it. This will become 2x plus 3. And I need to equate it to 0. So 2x plus 3 is equals to 0 and x is equals to negative 3 over 2. So we have one point only. That means either it will give me maxima or minima. So we have to double differentiate it and we got 2. That means simply dy over dx is greater than 0. That means this point is going to give me minimum point. So this graph has a minimum point, no maximum point. Obviously, because this is a quadratic curve, so it only has a minimum point. That means like this. So it has only minimum point, no maximum point. Now there is another curve g of x equals x cubed plus 4x squared plus 3, and we have to find the point of inflection. We know the point of inflection is where the double differentiation is equals to 0. So let me differentiate it one time. Will give me 3x squared plus 8x. So double differentiation will give me 6x plus 8. And we know the point of inflection is when double differentiation will become 0. That means 6x plus 8 is equals to 0 and x is equals to negative 8 over 6 or negative 4 over 3. So that's the point of inflection. So that's it for today. In this video only I have explained you the basic theory of maxima and minima and how to do some questions on it. These were only the basic questions, but these questions are very helpful to solve any question. So in the next video we'll be doing questions on maxima and minima, and then we'll be doing questions on the applications of the differentiation. So that's it for today, and if you are looking for one-on-one live online classes, let me tell you that the recorded sessions are not that interactive as compared to one-on-one online classes. If you are taking advantage from it, that's very good, because these are also helpful. But for some students, or we can say sometimes it happens that we got stuck at particular topic or particular question. So in that case, one-on-one live online classes are very helpful. So if you are looking for that, classes are starting at just £8 per hour. Or if you're looking for classes for any year from year 1 to A levels for any subject, all you need to do is just book a free demo, and for that just email us at exactacademy@gmail.com. And if you're looking to access these free worksheets, just visit exactacademy.com. So that's it for today, guys. Bye everyone, take care.